Hello, everybody, and Happy New Year. Welcome to 2026. Is that right? Yeah, that's right. Hanging with Hobo Live. I hope everybody's had a wonderful holiday season. Merry Christmas and a Happy New Year. Hope all your friends, family, and loved ones have stayed out of the hospitals and jails. And if they did get picked up or sent, they've been released or got out on good behavior. Uh, I'm actually glad that it's in our history. It's in the past. Let's have a good year going forward here. Uh, Last live stream, I addressed a request from Bruce about how to design a maze, and I was like, "Well, it's pretty easy to do, but then what do you do with it?" And so I had the idea of creating this tilting maze box. And I thought I was going to have it ready before going live today. I had That's the first prototype. This one has been disassembled and reassembled and put back together. I don't know how many times. I have played and played and played and tried and tried and tried to get the geometry down, and it has whooped me. And I don't know which math it is that's required. I don't know if it's algebra or calculus or which one it is. I never went past algebra 2 in school, but even if it's algebra that's being used, I don't recall enough of it. That's okay. I don't have to know it. I don't have to understand it. I just need to know what I need to have happen in order to get the clearances and tolerances to work. And I use AI, specifically ChatGPT, to do that math for me and to double check myself and see how things are going. So, what I and I seen someone mention last week that they would like to see the comments on the screen because they're watching it on TV. So I learned how to do that there. So if you don't like that or if it's in the way, let me know, and we'll leave it or change it or do away with it. I don't know. I could make it bigger, but I don't want to make it bigger because it then gets in the way. So I have I've finally today, after working on this thing all week, I finally had an aha moment. I finally had the breakthrough that I needed to get this thing built correctly. And it wasn't with the help of ChatGPT. I finally understood how this thing needed to be designed, what needed to happen, when and where, and then what that flow chart needed to be, how the design needed to take place. You do this first, then this, then this, then this. So I finally figured that out without ChatGPT's help. And that's the one thing that I don't like about, because artificial intelligence is not intelligent. There's nothing intelligent about it. And it is, instead of it is programmed to placate you. It is programmed to tell you what you want to hear, not always tell you the necessary truth or to tell you when you're wrong. It will just give you the answer you're looking for. Where that's a problem when designing is if you start out and think of this like building a house. When I'm designing this thing, I started from the ground up. You're building a house. You got to build your foundation, set everything, and then you put your walls up, and then you put your roof on. Well, designing this, I finally figured out that you can get it done so much more easily and accurately if you start from the top down, working in the reverse order. And had ChatGPT told me that whenever I was starting my design process, it would have saved me a week's of struggling and trying to figure out which way was the best way to go. And what I would like to do tonight, hopefully this will be something you guys, because what I like to do is teach you guys. I like to teach you how to do this. I will have this finished piece on the website, but I feel like, and I get enough feedback from a majority of the viewers, they really appreciate learning how to do these things. So, and Chris says, yeah, sometimes the foundations start at the top, and this one does. And I'm wondering what that's going to look like now with the comments on the side. There we go. Yeah. So, what I'm going to do is I was working on, I thought this was a finished piece. I thought I had it. I even had a video, assembly video, putting it all together and ready to go. And I was working on a video to post for this week. But after getting it all the final assembly done, what I thought was the finalist, it didn't work. So I wasn't able to post that video, but I have a good part of that. And what I think would benefit, because I feel like when you're learning, sometimes you learn more from your mistakes, to see what not to do. And I want to share with you the process that I went through to get to this. And then once I get through with showing you that process, you'll see, okay, well, now I understand how you started figuring these things out, because everything that I learned here was not wasted. I just did it in the reverse order. And that's why it's not working for me. And I've got to redesign the entire layout of this thing in order to make it work right. So what I'm going to do is hopefully press a button, share a video that, and I'll be watching your comments and questions, and I can act and interject here and there. But I want to show you the entire process that I went through using ChatGPT. I was using this to gain the information, the structural layout, the mathematics, the dimensions, because, all right, well, if this box opening has, a 295 millimeter square opening, well, this can't be 295 millimeters. It's got to be smaller. But how much smaller? How much smaller is too small? A lot of things have to go into the design and thought process. And that's what this is going to show and share with you the information that I was getting fed back to me from ChatGPT. So hopefully you find this informative and interesting. And then once this is wrapped up, I'm going to go into Lightburn and show you how I'll use the information that I have now gleaned over the past week to lay this entire thing out from the top down. Because if this is something, a tilting tabletop could be great fun for a maze, or if you wanted to do anything else. There's and I think it's basic geometry, which I hated geometry. That came in between Algebra 1 and Algebra 2. And I think I slept through most of that. Slept through it and pulled the blonde-headed girl's hair that sat in front of me when I wasn't asleep. So hopefully when I hit this button and share this with you, you're going to see the video and hear it. If, in fact, if one or two of you, Chris, Bob, if you guys can just do a good audio or thumbs up, audio sounds good, and let me know that you are hearing this. And then, like I said, then we'll get into what I hope is going to be the beginning of the final design process. We won't go through the whole thing, but I'm just going to show you one side and how I put it all together, get it out of here, and into Lightburn. So, all right, let's see here. Full screen and play. Play. Why ain't you playing? Oh, it's thinking. So during a previous live stream, one of my supporters had reached out and asked for assistance in creating a maze. Good audio? And so I said, okay, well, that's easy to do. So I helped show how to do that during a live stream. Then I got to thinking about it. How could I incorporate mazes into some designs and something that'd be fun to create and fun to play with? A tilting, 2-axis tilting tabletop maze. Dials to control each axis, and the whole tabletop will tilt. And you can control that with the knobs instead of, holding the actual maze or something. So I said, okay, got the concept, but now it's how do we go from idea to a finished piece? And that works with, tilting axis on both X and Y. Well, this was the first prototype. Learned a lot doing that. We're working on the second one now, which I hope will be the second and final one. But what I wanted to do was show you how I used ChatGPT to help me minimize the stumbling blocks and make sure that I created something that was going to work the first time. And it does, but it can work better. And so I had to go back in and make 2.0, and that's what I'm working on now. But let's get into the complete design concept. So what I'm going to do is share with you a conversation and the thought process of how this piece came together using ChatGPT. So I opened up ChatGPT, and I don't like typing, so I will speak to ChatGPT. So I'll speak to you, and then I'll let ChatGPT speak to you. So I said, I'm thinking of designing a maze using Lightburn. The twist is the maze will be on a tilting tabletop. I'm thinking of using a cam setup to tilt the tabletop on the X and Y axis. I can see the basic concept in my head, but I'm struggling to see a fully functional setup. That complete design is eluding me. I'm thinking of putting a dial on the front of the box. When it's turned, it will cause the tabletop to tilt on the Y-axis, and a dial on the side of the box that would cause it to tilt on the X-axis. To accomplish this tilting action, I'm seeing 2 cams on either side of a dial that runs the length of each axis. The cams would be offsetting, so in a neutral position, the table would be flat. But as you rotate it in either direction, the top would tilt in opposite directions. What are your thoughts on the initial concept? And when I put that question to ChatGPT, it responded as such.
Your concept is sound and mechanically valid. What you're describing already exists in principle. It's essentially a manual 2-axis tilt table driven by opposed eccentric cams, just implemented in a compact tabletop maze form. I'll keep this factual and concise per your preference. Core evaluation, 2-axis tilt via cams. Valid. Front dial, Y-axis, side dial, X-axis. Logical separation. Opposed cams on a shared shaft. Correct approach. Neutral equal flat. Rotation equals bidirectional tilt. Correct. You are not missing a fundamental mechanical concept. The key constraint you're running into, the problem isn't the idea, it's over-constraint and binding. A rigid tabletop driven by 2 independent cam systems must be supported at a single pivot point, allowed to float slightly at the cam contact points. If the top is hard mounted at more than one fixed point, The system fights itself. Required structural layout critical. To work smoothly, the system needs 3 functional elements. 1. Central pivot non-negotiable, 1 ball joint, rounded post, or hemispherical seat, located at the center of gravity of the tabletop. This defines rotation without binding. Think camera tripod head, not door hinge. 2. Independent cam axes. Each axis has a single shaft, has 2 identical eccentric cams, 1 on each end. Cams push upward only. Why 2 cams per axis prevents twisting, maintains plane integrity. Cam 3, floating contact points. Cams must contact the underside of the tabletop via UHMW pads, brass wear plates, or captured rollers. No rigid fastening between cam and table. Correct cam geometry. Your intuition about opposing cams is correct. Both cams on a shaft must be same eccentric offset, clocked 180 degrees opposite. Neutrals both cams at midpoint height. Rotate CW, one side rises, other falls, tilt. Rotate CCW, opposite tilt. Diagramize why your mental model feels incomplete, because a cam alone cannot define rotation. Without a central pivot, one cam lifts, the other resists. Table binds or rocks unpredictably. Your brain is correctly detecting a missing degree of freedom. Recommended simplification, optional. If you want fewer parts, replace cam pairs with single eccentric cam per axis positioned off center still requires a central pivot. This reduces precision but works for a maze game. Light burn relevant design tip. When designing the maze, avoid sharp vertical walls, use filleted corners. Ball diameter should be 2 times wall height. This compensates for sudden tilt transitions. Bottom line, your concept is mechanically correct. The missing piece is a single central pivot. Cams must push, not constrain. Floating contact surfaces are mandatory. Once you add that pivot in your mental model, the entire system should click into place.
Okay, so there was a lot of good information in that. The non-wearing, it used some I don't know, some type of non-wearing thin plastic that you can adhere to the bottom where the cams are going to contact the plates as they're rotating, so you don't wear. Without that, you'd eventually wear a groove into it. Well, I don't think this thing's going to, if it was in a commercial application, I could see that being absolute. But for this being just a little, home game that's going to be played with it for once in a while, or maybe for a few weeks and then put it on the shelf and collect dust, I don't think that's something I'm going to worry about. And it talked about the possibility of doing, 1 cam instead of 2, but I'm going to go with the idea of having 2. Well, you'll see. I'm going to have 2 cams on each axis, a total of 4 cams. But it come up with some really good information about how to keep it from binding and creating a truly neutral position with the cams. So I'm like, okay, let's push this a little bit further. And I said, well, if I were to design a lattice that went under the maze top that allowed for the cams to rotate and contact the table without interfering with the lattice, with the lattice having a single point in the center designed to hold a single marble in the center with the cams protruding just enough to tilt the table but not lift the table off the center marble, will that work? And it replied, let me get down here where, there we go, read.
Yes, that will work if a few constraints are met. Your idea is mechanically valid. Why it works: the center marble acts as a spherical pivot, allows rotation in all directions. The cams only push and never pull, correct. The table is never lifted off the marble, prevents loss of control or chatter. A lattice underside gives clearance for cam rotation, fine. This is functionally equivalent to a ball joint tilt table. Critical requirements, non-optional. 1. Preload on the center marble. Gravity alone is marginal. Add table weight or light spring preload or shallow conical seat. Goal: marble stays captured at all tilt angles. 2. Cam height limits. Maximum cam lift must be less than the vertical travel that would unload the marble. In practice, Cam lift 40 to 60% of allowable tilt height. This prevents the table from floating on the cams. A has lattice stiffness. The lattice must be torsionally stiff, symmetrical. If it flexes, tilt becomes nonlinear, ball control becomes unpredictable. Contact interface. Cam to table contact should be rounded cam face or flat cam square pad. Avoid sharp cam edges, they'll dig in and bind. Marble size guidance. Marble diameter, half meniscus quiescences. Larger equals smoother motion, less point loading. Small equals higher wear, twitchy response. Failure modes to watch for. Too much cam lift, table loses center contact, no preload, chatter at neutral. Weak lattice, twisting instead of pure tilt. Cams misclocked, diagonal bias. Verdict. Your lattice plus center marble pivot concept is sound. It will produce smooth, intuitive tilt. It's laser friendly and elegant. You've effectively reinvented a kinematic mount using hobby scale parts. As long as the marble remains the sole constraint point, the system will behave exactly as you're envisioning.
So I'm learning more, and I'm designing in Lightburn as I go with this, putting some potential designs together, making mistakes, and I'm going to include the entire journey of this where I'm implementing parts and creating parts of the design. It's like, oh yeah, you may, but then I may or may not end up having or using those in the final piece. But I'm going to show you this entire journey as we go. So next I asked it, I said, well, how about a simple disc cut out and glued to the center underside of the table with an inward offset cut out of to allow the pivot marble to engage in the. So essentially I was cut out a ring, glue it in the center, and then put the marble in the center of that ring. And I won't go into the whole part of this, but it said, yeah, it's actually better than leaving it flat on the underside. So it goes in and telling me all about how to do that and why it works. And then it kept talking about this ultra high molecular weight polyethylene. That was what it was talking about to prevent it from wearing, and it actually self-lubricated. This was way more than what I needed to do. So then I went on down. It says, well, what about the clear plastic sheets I purchased for using for picture frames in place of the UHMW? And said, yeah, that'll work. And we go on, and I end up not doing any of that because I don't think I'm going to need that for my home game. Then I said, well, when it comes to positioning the cams, closer to the pivot point or as far away as possible? And it says,
as far away as possible. That's the correct placement. Check why distance matters. The cam produces linear lift. The table responds in angular rotation. Angular change equals lift to distance from pivot. So farther from pivot, smaller lift required. Finer control, lower contact force, smoother feel, closer to pivot. Steeper tilt per degree, higher force. Jerky, non-linear response. Practical guidance. Place cams near the perimeter of the tabletop. Keep them symmetrical about the pivot. Leave enough margin so the table doesn't teeter off the pivot. The lattice remains stiff. Rule of thumb, cam radius 70 to 90% of table half width. Secondary benefits. Reduced wear, lower cam eccentricity needed, easier neutral tuning, better maze control. Bottom line. Maximum radius from the pivot gives better leverage, smoother motion, less force, more precision. For a manual tilt maze, perimeter placement is optimal.
Should the cams truly be cam-shaped, or would it be better if they were hourglass-shaped? A true cam shape, 180 from one another, would have only one lifting point on each axis. The hourglass shape would create two equal lifting points on each axis. And it replied,
Hourglass shaped is better for your application. Short answer, yes, use the hourglass. Why a true eccentric cam is suboptimal. Here, A simple eccentric cam has one lift lobe, creates a single contact point per axis, produces asymmetric force, encourages yaw and twist in a thin tabletop. It works, but it's touchy. Why the hourglass shape is superior. An hourglass cam is effectively two mirrored eccentrics on one shaft, self-centering, force-balanced. Mechanical advantages: two equal lift points per axis, symmetrical loading, reduced torsion, smoother neutral zone, better tactile control. This matches your lattice marble pivot design extremely well. Required geometry important. To behave correctly, the two lobes must be identical radius, identical eccentric offset, clocked 180 degrees apart. The waist must clear the lattice at full rotation. And neutral behavior. Waist under the table equals neutral. Rotate CW, one lobe rises, opposite falls. Rotate CCW reversed. You get bidirectional tilt without dead spots. Fabrication notes: cut as, laminated profile, stacked layers, or single thick disc if material allows. Light edge rounding reduces wear. Add plastic wear pads on the table. Bottom line: hourglass cams give balanced, predictable tilt, less binding, better feel, more forgiving alignment. For a precision feel device like a tilt maze, the hourglass geometry is the correct choice.
There are still some caveats that I have not ran into in my mental design process. I'm not doing any other software other than Lightburn. I'm not using any 3D CADs that help me see those interferences as you're designing. So I'm having to do all this in my mind, and that's a scary place. I've told you. So initially I'm thinking, okay, well, the hourglass shaped or two bulbous sized or shaped cams are going to be the trick. But there's a problem I have not encountered yet, which we'll get there. Turns out the hourglass is not the way I want to go, or the way I end up going. So I asked it, I said, if using the hourglass cam shape, when is a neutral position, there will be not, or okay, yeah. If I was using the hourglass cam shape and I had two on each axis, that's 8 points of contact plus the marble in the middle, that's 9. I said, if I use the hourglass cam shape, when in a neutral position, there'll be 9 points of contact with the tabletop, 2 on each cam and 1 in the center marble. Or should the cams be positioned so that there isn't an opportunity for this to happen? And
good question. This goes straight to kinematic correctness. Short answer: you do not want 9 contact points. Yes, you should position the cams so that this cannot happen. Why 9 contact points is a problem. A stable, predictable mechanism needs the minimum number of constraints. Your system needs 1 pivot constraint, center marble, 2 lift constraints, 1 per axis. That's it. If all 4 cam lobes contact simultaneously, the table becomes over-constrained, load paths fight each other, motion becomes sticky, neutral becomes vague, small errors cause binding. The table should never be supported by the cams alone or evenly by all of them. Correct contact strategy. Neutral position, center marble always in contact. Only 1 cam lobe per axis touches lightly. The opposing lobe is just clear, paper-thin gap. That gives 1 pivot, 2 controlled supports, total effective contacts, 3. How to achieve this with hourglass cams. Method 1 recommended: height bias, machine or shim cams. So 1 lobe is 0.010 to 0.00 meters taller. The opposite lobe never quite reaches the table. This preserves symmetry in motion while eliminating double contact. Method 2, table underside geometry. Slightly crown or relief the contact pads. Each axis has 2 pads, but only 1 can touch at neutral. This is laser friendly and reliable. Method 3, cam waist clearance. Increase waist relief. So neutral is carried by the marble. Lift begins immediately on rotation. No flat resting. Region. What you do want: marble equals always loaded, 1 cam per axis equals active. Opposing cam equals floating. Bottom line, multiple simultaneous cam contacts equals bad. Over constraint equals binding and inconsistency. Design so neutral has exactly 3 constraints. If you control that, the hourglass cam remains the best solution.
So here I'm still thinking about the hourglass cam shape. And I'm making progress in here, and like, okay, I see it. I'm starting to envision how these need to work, but I haven't actually started to create that X and Y intersection yet. And then I ask it, well, if the hourglasses were the exact same dimensions, but one of the two of the same on the same axis is rotated 3 to 5 degrees on the dowel when assembled, would that create the same, or that would create the same thing, wouldn't it? So instead of worrying about modifying and changing the shape of, I said, all right, just make them exactly the same for each axis. The 2 hourglass cams are going to be identical on the y-axis, but to create that the possibility for it to have 4 points of contact, I will rotate one of those on the dowel itself so that you're only going to have potentially 1 or 2 points of contact from that particular piece. So I'm like, okay, I think that's the KISS answer here, the keep it simple, stupid method. So I said, hey, can I do that? Will that work?
Exactly. Rotating one lobe slightly on the same axis achieves the same effect. Here's why. By offsetting 3 to 5 degrees, the lobes no longer reach the table simultaneously at neutral. Only one lobe makes contact at a time. The other lobe is slightly floating. Net result, still 2 lobes per axis, but only one active at neutral. You preserve symmetry and tilt while preventing over-constraint. Practical notes: small rotation, 3 to 5 degrees, is enough to prevent dual contact. Larger offsets can slightly bias tilt, but small is safe. Ensure both axes are treated the same way for consistent feel. Verdict: this is a valid, simple way to prevent 9-point contact without changing the cam geometry.
This configuration should create this should create at most a 3-point contact, right? And it said yes. I'm like, okay. All right. Then I said, all right, I've been thinking about the hourglass shape of the cam opposed to the standard single-sided cam. If the cams are offset from each other 3 to 5 degrees, one of the cams would never actually come into contact with the bottom of the maze unless it got uneven. Is the hourglass shape actually necessary? Maybe standard opposing cams that were slightly rotated on the dowel 3 to 5 degrees to prevent the opportunity of both cams making contact with the bottom of the board at the same time, or is the hourglass shape needed? So now I'm starting to question, do I need to do the hourglass, or I still haven't got to the intersection of the X and Y yet, but I'm starting to draw. I'm like, okay, I don't know that the hourglass is going to be beneficial or even needed. And that's what I asked it, and it replied.
Short answer, no. The hourglass shape is not strictly necessary for your design to work. Your reasoning is correct. What actually matters, not the shape. The system only needs 1 active lift point per axis at any moment, bidirectional motion from a single shaft, no opportunity for simultaneous contact. You can achieve all 3 with standard eccentric cams if they are opposed 180 degrees, slightly phase shifted 3-5 degrees, located far from the pivot. The hourglass shape is just a geometric convenience, not a requirement. Standard opposing cams set. This configuration gives you 1 cam lifting while the other floats. No over constraint, full bidirectional tilt, simpler fabrication, easier tuning, shim or rotate. Mechanically, this is equivalent to the hourglass solution for a maze. What the hourglass actually adds. Hourglass cams provide guaranteed symmetry without tuning, self-centering neutral feel, 2 potential lift points if geometry drifts. Those benefits matter more in high precision fixtures, heavier loads, automated systems. Your application does not require them, when hourglass would be worth it. Only if the table is large and heavy, you expect material movement over time, you want factory perfect neutral without adjustment. Otherwise, it's unnecessary complexity. Recommendation: practical. For your project, use simple eccentric cams, mount them opposed on the shaft, rotate one cam 3 to 5 degrees, use wear pads under the table, keep the center marble preloaded. This is mechanically clean, easy to build, and fully correct. Bottom line, hourglass cams are optional, not required. Standard cams with slight phase offset work just as well here. Simpler design equals fewer failure modes. Your instinct to simplify is right.
Okay, so I'm making progress, and I'm in fact, I go through a whole lot of drawing and test fitting and conceptualizing in Lightburn for the actual dowels and cams before I even begin to draw the box and the lattice and everything else that's going to be needed. As far as the exact information, I had to rough out the box and create where the marble location is going to be, so I know where the maze tabletop is going to be setting on the marble, so I know where the cam is going to come into contact with the bottom of that maze. So I have to have that geometry prefigured so I know how to design the cams. So, and I'd ask us, well, I like the idea the hourglass shape provides an easy to fill neutral position. For that reason alone, I think I will stick with the hourglass. But I didn't. And it goes on and says, yes, it will work. But initially there, it said, yeah, well, it's not necessary for this particular concept. Only if you were going to be doing something that you needed super, super precision. So I told it I was going to stick with the hourglass. I ended up changing my mind. I'm not going to go over its reply, but it said, yeah, bottom line, if you're trading in the geometry, you're trading a bit of geometric simplicity, but it's more forgiving in assembly. For this kind of tactile manual mechanism, that's the right trade-off. Well, I ended up not doing that. Then I said, I plan to use the outermost perimeter of the box being 290 millimeters. The material will be 3 to 3.2 millimeters at its widest. Now, here what I'm starting to ask it about is the size of the maze itself. The maze is going to be a free-floating piece of material on the box itself. The maze is just going to sit on there, and we've got all our cams and everything. So if the maze is just going to sit on there, the perimeter of the box, the size of the box is predetermined. It is what it is. But this piece is going to be floating in here, and it's going to need to be able to lift and twist. So I need, what kind of clearances around the perimeter of that maze are required so that it can move freely without binding and travel as much as it needs to. So I said, okay, my dimensions are 290 millimeters. The material is going to be around 3 to 3.2 at its widest. This would make a piston fit maze surface to be about 283.6 millimeters. And obviously this won't work. By piston fit, what I mean is it will drop in there and it fits snug as a bug in a rug. And if it's piston fit or snug on all four sides, it can't tilt. It can't lift and move. I said, so obviously this isn't going to work. How much smaller will it need to be in order for it to tilt properly? How small is small enough? And this is where we get into that four-letter word, math. That I don't. We start talking about sine and cosine and tangents and all that. That's calculus or if that's or out. I don't think it's algebra, but I didn't get that far in high school. And I understand what needs to happen, but I don't understand how to do the calculations. And that's where this comes to play. So after asking it, how small is small enough?
You're thinking about exactly the right constraint, clearance for tilt. I'll keep this concrete and numerical. Given outer box inside opening, 209.0 millimeters, wall thickness 3.2 millimeters, piston fit opening 90.2 to 83.2 6 root millimeters. A true piston fit equals 0 tilt allowed. What clearance must accommodate? Clearance must cover 1. Maximum tilt angle. 2. Cam lift at the perimeter. 3. Manufacturing tolerance. 4. Wood material movement. Practical maze tilt angles. For a marble maze, useful tilt must 5 degrees to taste 8. Above 10 degrees, marble becomes uncontrollable. Will design for 8G max. Clearance math simple and safe. Edge rise due to tilt. Edge rise fact W2, where's W equal table width equals 283.6 millimeter. Fact 283.6 to approx 141.8, 0.1405, 19.9. That's vertical rise, not lateral clearance. The horizontal intrusion into the side wall is T, approx T, where T equals table thickness 3.2 millimeters. 3.2 sunny is 0.45. That's per side. Real world rule, laser cut friendly. Add 0.5 to 75 mm per side for tilt, 0.5 millimeter per side for tolerance and finish. Recommended total clearance 1.5 to 2.0 millimeters per side. Final recommendation, box inside opening 283.60 millimeters. Top size 279.2 and 80.5 millimeters. I target 280.0 millimeters square. This gives smooth tilt, no wall rub. Margin for cam variation, no visible slop to the user. Bottom line, small enough is not a guess. For your dimensions and tilt range, open quote, 3.5 millimeters, total undersize, 1.75 millimeters per side is the sweet spot. Close quote, that will feel intentional, not loose.
Did you get all that? I didn't, but all that matters is it told me what the bottom line is, what it needed to be for those dimensions. And it's a good thing I didn't have to do all the math. And I could have actually told ChatGPT, forego all the explanations, just give me the answer. But you can see here that there needs to be a lot of thought that goes into, especially when you're creating mechanical pieces. There's a lot to consider. It's and that's why the price of my designs have the price that they have. Even when I'm using ChatGPT like this, it's having the recognizing the need, even though I don't know how to do it. I recognize the need for these allowances and all that, and I can get by with hopefully just version 2.0 and have a design ready for you guys. All right, so I said after looking at the room needed to access the knobs and rotate each axis, the outer perimeter needs to be reduced to 285. So I changed the dimensions. Once I said, okay, well, because at 290 or whatever it was I started out with, I didn't have enough room, there you go, for the knobs to protrude enough to work with them. So I said I needed to reduce the box size so I had long enough dowels that could rotate the tabletop. So I gave it new dimensions, it did the new math, and it gave me the new sizes. And then I said, okay, now after sketching this out, and this is where I finally realized, wait a minute, doofus, you got X and Y axis. One's going one way, one's going the other. And you got two dowels. Well, they can't intersect each other. They've got to be on different planes. One's got to be above or below the other one. So I said, all right, sketching this out, the two dowels will need to cross at the center of this design. Obviously, this cannot happen with the dowels at the same height as one another. One will have to be lower than the other. This should not be a problem as long as the rotational center point for all four cams are the same. Correct? And get down here. Here we go. And read aloud.
Yes, that is correct. The dowels do not need to be at the same height. What actually must align. The only critical requirement is, open quote, the effective lift center of each cam pair must reference the same pivot point, close quote, dot, not the shaft height, not the dowel center line, only the cam contact plane relative to the pivot marble. Why different heights are fine. Each axis is independent. The y-axis shaft tilts the table front back. The x-axis shaft tilts the table left right. The table doesn't care where the shafts live. It only feels where the contact points are. As long as all cam lobes contact the same underside plane, the marble pivot is the highest fixed reference. Cam lift is measured from that same reference. The system behaves correctly. Practical implementation rules. 1. Shaft height offsets. One dowel higher, one lower fine. Just in short, max cam height is equal on both axes. Neutral height matches at the table underside. 2. Cam geometry. Cam eccentricity can be identical or slightly tuned per axis. Shaft height compensates automatically. Shaft 3. Crossing clearance. Leave at least 1 to 2 millimeter clearance at the crossing. Don't let the dowels touch or rub. Common mistake to avoid. Do not try to align. Dowel center lines, shaft heights, cam base circles, align, cam contact height at neutral pivot, marble height. Bottom line. Crossing shafts at different heights is normal. Rotational center of the cams does not need to be coplanar. Contact geometry is what matters. Your design remains mechanically correct with staggered dowel heights.
So I'm starting to get some sketches done in Lightburn, and in my initial draw up of this, I did make a mistake. I actually made several mistakes. But even when I thought I had them all corrected and cut out the first prototype, there were still some adjustments that needed to go back and be made. But one of the things I failed to do is I failed to accurately allow for the height of the pivot point of the marble. I didn't have that position correct. But I ended up drawing and sketching all this out in Lightburn. And in ChatGPT, you're able to upload images and ask it to, hey, look at these, tell me what you think. So I don't know if I can. Yeah, I can. So here is an image, and I'm going to show you this and kind of explain a little bit. This is going to look very confusing, but this over here is the lattice. The blue is just the lattice shape. The green is the cams. The pink is the dowel. And this area here is just cut out waste to decrease the weight of the overall piece. And then the orange here was that ring that I was going to put in the center to position the marble for the center point. Now, this is a top-down view looking at the lattice and the positioning of everything. This is a side view. This is, say, I don't know if this was X or Y, and this was the other opposing. And then this is the two combined. So here you can see I've got one dowel up high, one down low. And whenever you position them with one over the other, you got plenty of clearance here. And you can see the shape of the cams that I've created. So, and they're positioned, if you were able to zoom in here, the points of contact are exactly the same, even though the shapes are completely different. So I said, I'm going to share a couple of drawings with you. The leftmost is a top-down view. The red layer is the outer perimeter. The blue layer is the lattice that will rest just beneath the maze top. The black layer is the perimeter for the maze top. The green layer represents the cams. The pink layer is the dowel positioning, and the orange is the center pivot ring. There will be a ring on the lattice and on the bottom of the maze. The top right is a side profile that shows positioning of the axis in relation to one another. Right, middle, and bottom show the individual side profiles and showing the positioning of the cams. Do you see a problem so far? And it replies,
I see what you're doing. And overall, this is a coherent, workable layout. Nothing jumps out as a fundamental flaw. I'll go through it systematically and point out the few things to watch, not redesign it. High level verdict. Geometry is sound. Degrees of freedom are correct. No obvious overconstraint. Shaft crossing handled correctly. Cam logic matches the earlier discussion. You're past the concept risk stage. This is now in tolerance and execution territory. Hashtag top-down view left. What looks good? Cam placement near the perimeter, correct leverage, symmetry about the pivot, predictable tilt, central marble ring alignment, correct reference, lattice clearance slots, you've anticipated cam sweep, no issues here. One thing to check, the green cam sweep slots in the lattice, make sure they clear the full cam envelope, not just the lobe. Include a little angular over travel, my 5 to 10 degree safety. This is a common looks fine in CAD, rubs in reality point. Shaft crossing, you handled this correctly. Shafts at different heights, correct. Crossing at 90 degrees, correct. No attempt to align shaft center lines, good instinct. One caution at the crossing, leave at least 1 to 2 millimeter vertical clearance. Wood plus dowels plus loose or slightly. If they can touch, they eventually will. Side profiles. Top right, both axes together. This confirms one shaft higher than the other, both cams contacting the same plane under the maze. That's exactly what you want. No issue. Individual axis profiles, middle and bottom. The hourglass cam proportions look reasonable. Things you got right, waist narrower than lobes, neutral detent, lobe height modest, won't unload the pivot. Contact happens near lobe peaks, good control region. One subtle check. Make sure neutral waist height is slightly below marble supported plane. Cam lift begins almost immediately on rotation. You don't want a dead neutral where nothing happens for the first few degrees. Center marble rings, orange. This is well thought out. Just verify. The ring on the lattice does not constrain lateral motion. Only the maze underside ring defines the pivot socket. If both rings try to hold the marble, you'll get binding. A load path sanity check in neutral, load maze, marble, base, cams lightly kissing or just clear. Under tilt, load splits, marble plus 1 cam per axis. No moment where cams fully replace the marble. Your geometry supports this. The only real risk areas, all manageable. 1, cam to lattice clearance. 2, shaft crossing clearance. 3, accidental double cam contact if tolerances stack. All 3 are solved with plus 0.5 millimeters here and there. Slight chamfers, wax or plastic wear pads, nothing structural. Bottom line, I don't see a design flaw. I see a first pass build that will work and then get smoother with minor tuning. At this point, cut 1, dry assemble, rotate cams by hand. Watch contact points. You're doing real mechanical design now, not guessing.
It doesn't realize that this ain't my first mechanical design. The gumball machine I did without the assistance of ChatGPT, and that one was really challenging because that one I ended up having multiple gears, and I'm really proud of the way that come out. If you haven't seen the gumball machine, it is on the website, hobowithwood.com. It's a fully functional gumball machine. The only challenge is I've been told that the mason jar, or the jar that I used that I got from Hobby Lobby and mentioned in the design process, may or may not be available, but I think it's pretty much a standard mason jar opening. So I just didn't go with the real tall quart. I went with the little half quart just for looks. And you don't need that much gumballs, that many, they go stale and hard. So I've done some mechanical stuff, and it said, "Hey, you're doing some real mechanical designing now. You need to." All right, so it told me there essentially that, hey, you're on the right track, and that's going to work. If anything, now all you got to do is worry about the fine tuning. So, well, Robert, we're getting ready to start actually redesigning this. But if you got to go, you got to go. But I wanted you guys to see. There was a lot of time and effort and spent into fully understanding and grasping the mechanics that have to take place to make this work correctly. And let's see, stop screen share. Good. All right. Because what it said, it didn't see any problems. Everything looked like it was going to work great and was going to work. It didn't work. The geometry was off. And, and that's why I say it's, what is the point of the lattice? Well, the lattice is to add structural integrity to the box itself. Without that lattice up here, there is nothing holding the top of it square and in place. You've got the bottom, that's fully engaged, but you needed something at the top in order to keep the box square, to keep everything in its proper position. So that the whole reason of that is just structural integrity. That's all. So, but I learned a tremendous amount with my trial and error and figuring out what's actually happening and what needs to happen. And we're going to go over into Lightburn and play and show you how I use the tools in Lightburn to take what's in here and start to begin and get the necessary pieces that I need, and how and what you have to think forced. It's like when you're designing something like this, it's like playing chess. You got to be thinking 4 steps ahead. The biggest place that it failed me, and this is what I was saying earlier in the stream before I started that, ChatGPT or any AI is not going to come out and tell you, hey, dummy, you're doing this wrong. Or, hey, stupid, you need to do this first. They are placating machines. They are going to, oh, you're just so smart. You're just the greatest thing since, it's great for doing the math, but it told me, oh yeah, thumbs up, looks good. Do it. It's going to work. It didn't work. What you have, if you're wanting to if you're going to do your tilting box yourself, if you're not going to get this file from me and you want to do your own, here's the takeaways from all the time I've spent this week in trying and failing. If you want a tilting table, the most important measurement, and I do the single most important measurement, is the center pivot point, the height of that silver pivot point. And in this case, initially, my concept, I did not realize the importance. Let me get some marble out of here so I can quit listening to it. I did not realize the value of that marble. Oh. And initially, I've just got a single hole cut in there. And the height, the pivot height, was only the height of the marble setting in that hole. And since it's setting in the hole, it's not even the full dimension or the diameter of the marble. And I'm going to show you how you calculate that too. In order to get a box like this, ChatGPT just said the optimum tilt for gameplay was about 8 degrees of rotation. Well, it told me that. But at no point during that entire conversation that you just watched did it ever mention the overall height of what needed to be for that center point to achieve 8 degrees of rotation. Only after I failed and failed and failed, and then realized that was what my problem was, I went back to ChatGPT and said, hey, given the dimensions that you already know, you know the width of the size of the box, you know the size of the maze, and you know that I want to have it at an 8 degree tilt angle, what's that value need to be for the center pivot? how high does that pivot point need to be? And it goes into all of its magical sines and cosines and jumbling, throwing numbers at me and everything. And it comes back and it says, your window should be between 19 and 24 millimeters. Well, that's almost 25.4 millimeters is an inch. I've got less than 16 millimeters there. I'm almost half of what I need it to be. I need to greatly increase that pivot point. So I'm like, oh boy. At no point during the whole design process of all these conversations that I'd had with this thing did it ever tell me that basic number. Hey, your pivot point needs to be 20 millimeters in order to achieve 8 degrees of rotation. Well, what if you don't want to make a box this big? What if you want to make a box that's smaller or something else? Let's jump over here. Let's see here. In fact, I had a couple of starred comments. I want to address these here. Chris said, for mechanical design, I found you need to start by describing the result. With the AI, it doesn't matter. They're always going to leave stuff out. And then Carl asked, can you ask for you can ask for can you ask it to provide a design? Some of them are better than others. ChatGPT is terrible. ChatGPT is not one for creating any type of graphic. Its artwork is horrible. You can ask it to generate SVGs of something like this, and it creates people with 6 toes and 4 eyes and 2 tails, and it's not reliable. You can't use it to generate actual designs. You can ask it, you can show it your design and ask it like I did, do you see a problem here? And it said, no, it's going to work great. But there were problems and it did not address those. And then Led Zepp says, you're actually working on the arcs followed by at the top. And see, I see what you're saying. And yes, I understand what you're saying. But I didn't realize that's what I was doing. I just knew what I needed to make happen. I got street smarts, but not book smarts. Go back. I love designing, but most people do not realize all the effort that goes into designing an item and the many changes until yes, it is. Last time I asked AI to solve something for me, it said, you're having a laugh. Go get a cup of tea and think about kittens. All right. So let's jump over here to Lightburn and show you how you figure out how high does your pivot point need to be. And then are you going to use, and I found that using the marble is perfect for creating a nice round pivot point. That glass marble is going to be a non-wearing piece and shouldn't be an issue. All right, so over here to Lightburn. So here's the design that doesn't work, that I've got completely done up and cut out numerous times, and now I got to. I'm not going to scrap it. I'm going to try and salvage it by redoing the things. I thought you were taking 2 bungees attached from one side to the other, crossing. No. Each pulled by its own dowel, winch, or pulley. Yeah, bungees would be something. And hey, I love to say it. There's always another way. Could you use a pulley system, something like that? Yes, you could. Is that the right way or the wrong way? No, it's just a different way. I like using, when I'm creating, I like using what I have in my environment, which is the wood. And I did, I've been salvaging my marbles. This is on the design somewhere or in the website somewhere. It's a lamp that I made, and it has the top that's missing. And I've been salvaging the marbles out of it, using it for different things. So I had marbles here and I had wood here. And so that's what I decided to use. All right. So let's go over here and start with our knowns. Let's say if you're going to use a marble for a pivot point and it is a 16 millimeter marble, and you're going to create that pivot point by having it rest in a hole, and the hole you're going to cut is going to be smaller than the diameter, and it's going to be 15.5 millimeters, and 3 millimeters is the material thickness. And I got my aspect ratio locked. Let's do that and go 15.5. All right, so that is a cross section of the hole that you're going to cut out in order for the marble to set in. And you see that that's obviously smaller. Well, if you take this and you start moving it down until you get it to where right there's how far that marble is going to set down in that hole. So now if you were to take and measure from the top of the marble straight down to that top surface, that right there is going to give you a 10 millimeter pivot point. The height, it's going to be 10 millimeters above the surface. And that's what my initial design was only 10 millimeters. I needed to double that. That's why I had practically no rotation or no tilt whatsoever. Now let's figure out the if you didn't already know that 20 millimeters is what I wanted, I needed to figure out how high did it need to be to obtain 8 degrees of rotation. This is what I would do. If I've got a piece that we'll say is going to be 285 wide and 3 mil thick. That's going to be the maze, right? That maze is going to be sitting on the center there. That's where that maze sits. Now this represents the lattice, and if that's also 295, we're going to say, or there you go. If I want that to rotate 8 degrees, I need it to tilt 18 degrees. What did Chris say here? If the pivot point height becomes an issue, try ball bearings instead of marbles. Greater variety of sizes. Well, I've got a solution for using the exact same marble. Real simple fix. And actually, this is actually even my approach to this for creating the correct pivot point height is better than going out into the real world and going to Harbor Freight or going to Lowe's and Home Depot and different places trying to find the right size bearing. I know that I've got a 16 millimeter marble, and I know that when it's sitting in a 15.5 millimeter hole, that it leaves 10 millimeters of height. I know that. Well, all I have to do is create a base that will sit ever how high I need it to be above the lattice that hole will be in, that the marble will sit in. And now I can control to within a fraction of a millimeter or whatever right height, or pivot point height I need it to be. And I do completely understand, totally understand. All right, so here, if I would have, and see, I didn't fully understand the geometry that was taking place. I didn't understand what was happening when I was asking the tabletop to tilt. And we're creating a triangle with the pivot point being one point of the triangle, and then your cams being the other 2 points of the triangle. There's 3 points of contact, center point, and then the point on the X and the point on the Y. And you need to be able to drop from that center point. It needs to drop, down and away. in order to get that tilt. So that tells you where, now you can figure out, using that information, you can use that to figure out where the cam axis contact needs to be. And we're going to look at all that here in just a second. First, I'm just going to show you here. I need 8 degrees. I need 8 degrees of tilt. Well, here in this position, which is how I designed it originally, if you take and select that, make sure your anchor point is in the bottom center, and I want it to rotate it 8 degrees. See what happens? It drops below the lattice. It will not rotate 8 degrees. Before it gets to 8 degrees, it's going to bottom out hard, and that's why this didn't work. I didn't understand that. And this is the, I wanted you guys to, and I appreciate, God bless you for sitting through all of that we went through, but I wanted you to see, the process and understand, because there was lots of good information in there, and I will use a lot to get my final piece. But in order to achieve 8 degrees of rotation there, I've got to lift that center point in order to get that full 8 degrees. And I know I just measured that was 10 degrees of rotate, or 10 degrees of height from the top of that marble to that, what was essentially the lattice. So I'm going to change my move tab to 10 millimeters and say, okay. And now if I take and select both of those and just move up, look at that. Look at that. If I only understood why I needed to have that to happen, I didn't understand it. I didn't understand it. And Carl, I'm the same way to the visual. That's why I can't do the math. I don't know the math, and I don't understand how or why to do it. But I didn't know what to look for. That's my initial questions to ChatGPT whenever I was wanting to figure out this designs. That piece of information, I didn't know that I needed a center pivot point. And it told me flat out in the very beginning, if you go back and watch it, it says the one thing you're missing is your center pivot point. You need that in order for the system to work. But it did not stress to me how crucial the height of that center pivot point was, nor did it express, and I'd already given it the dimensions of the top of the maze and all that, not initially, but halfway. And it could have said, hey, you're doing this. Now you also need to incorporate that, and your pivot point needs to be this. Well, it doesn't volunteer the information that you need. It will give you the answers that you want and not tell you what you need to know. Let's see here. So now I just showed you how you can create the tilt in Lightburn, and then I already knew the answer was 20. So I just added the 10 millimeters and got it up there, and you can see that the clearance is perfect. 20 millimeters is exactly what I need. But if I didn't know that, if I had my my movement set to, okay, control arrow is 1 millimeter. So let's put this back down. And there's where you're starting. It's like, okay, well, how high does it need to be? And you can use your measurement tool to measure from there straight down and say, okay, well, there's 10 millimeters. That's where I'm starting at 10, and it don't work. So got them both selected, and my control arrow is 1 millimeter. I can just start moving it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And okay, now I know an additional 10 millimeters is all I need to clear my pivot point height. And Chris says, I know the math, but it's faster and easier to do it your way. That's what I would have done. Yeah. The problem is this, to visualize it and is so much easier when you know what you need to be looking for. I didn't know the center point was the key. The center pivot point to a tilting table of any type is your center pivot point. Now, So there's where it needs to be. Well, if I had that 15.5 degree, or actually, you know what? It's going to be bigger than that. I'm going to say we're going to go width be 25 millimeters, 25.4. We make it a full inch and 3 millimeters. Put my anchor point back in the middle and let's bullseye those. All right. So now I need to get this to where it's going to be just intersect. Actually, you know what? I need to get that actually at 15.5. So let's put that back at 15.5. That's going to be the diameter of the hole that I'm cutting for this to sit in. And, oops, wrong button. There we go. There. So there is where I'm going to duplicate that and stretch that out and tell that one to be 25.4. All right, so there's a full inch. There's where the hole is going to be cut in this. And if this piece is the lattice and I need that to be up there, well, then I'm just going to take that and figure out what, and I'll get it within a 10th or a 15th of the millimeter there, real close. Then all I need to do is that. In fact, we're going to duplicate all that. Control D, duplicate it, bring it over here, and then say A, subtract B. And then duplicate that. What is the measurement? There is right at 4 millimeters. So I'll do 2 by 3. It's be 3 wide and 2 tall. And put it in the bottom center. Oh, I'm not showing the screen. Sorry, guys. I just realized that. Sorry. Yeah, dummy. All right. So I've just drew a square here. I've calculated whatever the height needed to be for that, where it's going to be sitting in that. And then, in fact, let's just go back. Control Z. There we go. There. So there is the hole. That's a 15.5 millimeter hole. That would be cut for the marble to sit in. And I found out where the intersection would be in order for that to work out. So I would take that and I can delete that for now. I'm going to duplicate those two, bring it down here, and then say A, subtract B. That gives me the basic shape. The distance from here to here was 4 millimeters. So I need to make that to where those will interlock. So it would be 3 millimeter material and 2 millimeters tall. And it would be in the center bottom. And we need to duplicate that. And then say A, subtract B. And then put this one up there and say A, subtract B. And clean that up right there. But then those would interlock with one another. And the marble would sit right in there. And then you'd put a couple of tabs on here. Oh. Weld that all up and then put that on your lattice where the hole is now, and that's going to lift it up and put the marble in there, and you've had perfect control of setting your height of your pivot point. How about a socket on the upper table for the marble to set in? I asked about that in Chat GPT, and I cut it. I cut that video short because I know some people were starting to drop out. And it said that having two rings or having it could cause some constraints. It could cause some binding, and it didn't recommend doing two. Having the one in there fixed, okay. But doing it this way, I don't know. You could always try it, and then as long as everything was clean, smooth, sanded. Even it talked about using a little bit of oil and to lubricate things. It may help. It would definitely keep your maze top in position. A socket will give too much contact area. Yeah, that's what it's talking. It could cause some binding and some constraints. It talked about using a dimple, but we can't do that with our CNCs and our lasers. You could take your marble and tap it with a hammer and put a little dimple in it, but you would have to clock the cradle 45 degrees off. Don't follow you there. Don't follow right. You're talking about the cradle for the marble, and it'd be clocked 45. Why? All right. So that's how you start. And where I made the mistake is I started with my cams. I started with the eccentrics and figuring out the contact points and all that, and then started layering things on top of that. Where I messed up was not realizing the importance of that pivot point, or even the needing a pivot point, and then the importance of getting that pivot point at the right height in order to give you the necessary tilt. The edge of the cradle will interfere. It shouldn't. If we go back over here, because here, this is the cradle height right here, and the marble height's up there, and the table's here at full tilt. It's nowhere near it shouldn't interfere with anything. It shouldn't. Not that I see or I can envision. I would think that the top would slide when tilted. It does move ever so slightly, but because I did use the math from ChatGPT to tell me, hey, these are my outer perimeter walls. These are my hard constraints. I need it to move and tilt how much smaller, and it did all of that stupid math, the sine and cosines and this and that, and said, okay, in order to do that and tilt here, and your material is going to be 3 millimeters thick. Because another thing, if the thicker your material, the more it tilts, then you're going to run into interferences. If you had 6 millimeter material, you would run into interference quicker than you would with 3 millimeter material. So your 6 millimeter material wouldn't need to be smaller than the 3 millimeter material. So that value that it gave me, it took all that in consideration and gave you the perfect size. And what little bit of slippage is there is not enough to prevent it from working. The problem the reason that this one didn't work is it wouldn't tilt more than about 3 or 4 degrees, and that's not enough to make it a playable game. A small hole in the top, and that's I didn't want to put anything in the actual top of the tabletop, but that could potentially have two values. The maze is here, and if you put a small hole in the very center to sit on the pivot point, that small hole would also be visible here, and give your marble and your maze a place to come and have a final resting point. So that could actually serve two functions. That might be something I'll look at incorporating in the design. Now let's see here. Who said that? Carl said that? Yeah. Good thinking. And it wouldn't interfere with the game center because that would be the target. Only if the cradle was on both the lattice and the table. I don't follow. And Andy said, and you, if it wasn't smooth and polished, it's going to add additional drag. But and there's other things to contemplate too. It's ChatGPT said that gravity itself is not necessarily enough. You may need to actually add additional weight to the maze in order for it to tilt and move, properly. Being that I'm doing two layers, and actually, after playing with this a little bit, my final design may actually be 3 layers for the maze, and being 3 layers thick, it may add enough weight. The reason for 3 layers is because with the 16 millimeter marble and only a 3 millimeter wall, if you get enough speed and inertia movement, that marble jumps the wall. And it said that the walls of the maze needed to be at least, or the marble needed to be twice the wall height, I think. And here, since I got a 16 millimeter marble, we probably need about, ideally an 8 millimeter wall. So if I do 2 layers at 3, that'll give me 6. That'll give me better constraint and less jumping of the marble. And 3 layers, more weight. All right, so pivot point. Showed you how to figure out the angle. That also gives you the way to figure out how high your pivot point needs to be. And then let's see here. Okay, in my mind, I see the marble glued to the top and pivoting at the hole where the marble is placed. How are you going to glue the marble in the exact center? If you're going to put it in a hole and glue it in there, it'd have to be, perfectly centered. I ain't saying that it won't work. I'm just trying to envision how you're going to do it all, how you're going to set it up. And you don't want to have that. That's going to be a constraint, putting it in that cradle. That's going to be 4 points of contact on that marble, creating friction when it's needing to move and rotate. If it's glued to the top, then it's not actually rotating. That shouldn't create any additional friction. It's not moving there. It's moving with the top. As long as that cradle was sanded perfectly smooth and you had to make a little bit of lubrication there, then it may not be an issue. And like I said, I haven't done this yet. I just had it in a hole and had it sitting there. I had nothing holding it and constraining it. And this, trial and error will solve the problem. I've been, this week is nothing but trial and error. If the cradle is fixed to the top, I was fixing the cradle to the lattice. I don't know that it would matter either way where the cradle was fixed. I don't know that it would matter. All right, now let's quickly look at what you need to consider when you're doing it, because I put so much thought into these cams. And here's something, what I'm getting ready to show you is absolutely crucial. Here's another, because this is something else that ChatGPT was initially told me wrong. It said, hey, yes, do that. It's going to be the greatest thing since cotton candy. And it didn't work. And then when I realized it didn't work and I went back to it, it's like, oh, yeah, that won't work. Instead of doing that, you need to do this. So it's like, hey, yeah, great job. Oh, yeah, no, that's wrong. That don't work. Instead, because initially, well, I'll just show you. Let's go back over here. Initially, on my cams, my thought process was, keep ungrouping here. There we go. That if I took this, because the way my dowels work, I've got just, these pieces, they interlock with each other. So they're not round dowels. They're interlocking pieces of 3mm material, creating an X shape that will rotate. And I can use that X in order to put my dowels or my eccentrics or my cams on the dowel. And in order to prevent having all of them at the exact same height, so I didn't have the 9 points of contact, I initially thought that if I were to just simply come in here, and I even asked it, and it said specifically, rotate it 4 degrees. And I said, okay, well, I'll rotate that 4 degrees. So now I've got one here like this, and this one like this, and these mounted on the same dowel. So now they don't have, they're not going to make contact at the same time. So I thought, okay, well, problem solved. That don't work. Not only does it not work, it creates a problem. What did finally work is actually lowering the lobe or the cam on one side of each piece here. So if I undo that, put that back. If I were to bring this over, let's just duplicate this, bring it up here, and I bring a guideline down here to here. See, that is actually below. Let's actually bring up here, select it, and then select this one and Alt-Shift-V. Oh, that shows to be, but Alt-Shift-V did not put it at the center. Let's put it right at the top. Put it right there. There we go. So there is right on the line. We come over to the other one, though. It's a little bit lower. And what little bit? 1.1 millimeters. And whenever I finally come to the realization that rotating it on that axis didn't work and went back to it, it said, oh, yeah, no, that won't work. You need to lower the one lobe on that eccentric, and it needs to be lowered. And it told me one, whatever that came out to be. It was just a millimeter or just a little less than a millimeter. That had to be lowered. And I'm like, seriously? That's all? How's that going to make that much difference? But I cut it out, disassembled it, put it all back together, and tried it like a glove. Perfect. 1 millimeter. 1 millimeter difference. Didn't work. Binding, fighting, 1 millimeter, fluid movement. Who knew? GPT didn't know it initially because it didn't volunteer the information. Only after I presented it with the problem and said, oh, wait a minute, this will work. Oh. If the cradle is fixed at the top, no. Alt-Shift-V took into the difference between the height of the lobes. Okay, I figured it was just because of the curve, like it does in text. But anyway, so a millimeter of adjustment on one side of the lobe made that work. But now where that presents a problem is assembly. When you go to put these together, you have to make sure that you get those put together symmetrically. And by that, what I mean is when you slide these together on the dowel, This is the one that's lower. This is the one that's lower. And when you put these together, you need to have both of those lined up with one another. So you can see the S's are on the same side of the dial. And there, you can barely see it. Wait, where are you at? There you go. Oh, wrong way, Conway. But anyway, that way you're keeping the symmetry the same. You're keeping the geometry lined up. And that 1 millimeter adjustment made a tremendous amount of adjustment or correction. So now that I've got that figured out, I've got the cams figured out. I know about making that offset. I know about needing to have the 20 millimeters of pivot point height in order to get 8 degrees of tilt. Now I can start at the top and work my way down, start at the roof and come down to the foundation and get everything positioned correctly and into a box that will give me the proper tilt and work. Symmetrically or diagonally opposed, I've got them on the same position. Let's see here. There. Well, yeah. Because both of them were on the same side. They're not diagonally opposed. But now you got me asking myself questions. Do they need to be diagonally opposed? Because of the rotation? No, I think that would Chris, because it worked great. And I think putting them diagonally opposed would cause constraints. It would put it in because they would be want to fight. Yeah, I don't think diagonally opposed is correct. I think the way I've got them is the way you need them, because I've already tested this and it worked great. All right. So if I come back over here, well, I'll come over here and use this. Here's one of the side pieces that I've got mocked up. So there is the lattice. There's where the lattice snaps in here. So if I know that this is the pivot height, I can come in here, get rid of this right here, group that together, put it in the center, Alt Shift V, there we go. And then move that up. And actually, you know what? I don't even need that. That's the maze. But there's the pivot height. Now I need to give myself a little bit more height on the piece so that the maze stays inside there. So I'll just simply move that up a little bit. I've got my height, my pivot point. I know. We'll double check it. We'll say width is 290 and 3 and put it in the center. Alt Shift V. There we go. 290 is too big, so we'll take that down. I like that. I don't know. I'm guessing at that measure right now. I'm just looking at rotation. Now, if I take that and I rotate it, bottom center, rotate it 8 degrees. There it goes. It sits right there above the lattice. I got plenty of degrees, 8 degrees of rotation. So that's positioned right. That's where that needs to be. I can work with that lattice now. Now I need to figure out the height and position of my dowels. So we'll leave, and this is the outer dial. Here is the actual size of the dowel. Actually, you know what? No. In the very beginning, ChatGPT talked about a caveat or a design suggestion when using Lightburn, and it said use it said use filleted corners. And I'm like, radiuses. Use radiuses on all of your designs on these pieces. It actually adds strength. If you didn't know this, and I'm pretty sure, I don't know if it was the DC-9 or which one it was. It might have been DC-9. It was the very first jet that went up above, pressurized jet aircraft. The first, the large fatalities and failures were because of the windows in the fuselage cracking and blowing out. And the reason was they was using square corners on all the windows, and they couldn't take the stresses of pressurizing, depressurizing, pressurizing, depressurizing, and ended up cracking the aluminum. And then once it's pressurized, blowed out, some people out, crashing planes. So that's why you have all rounded windows in your jets now. Same thing here. When I'm doing these pieces, anywhere that I could get away here, they needed to be square, but here I didn't use corners. I added material here around where it intersected to strengthen that up, but then I made sure I took the corners off of this so I could add more strength to where that intersected and locked up. The British Comet, okie dokie. That was the first one with the blowed out windows. All right. So if this piece, let's break them down to individual pieces. If this piece is 30 mil wide, get rid of that guy. Then that is the actual, and my pallette's gone. Bring it back. There we go. Put that in the center. So there is the actual dimensions of the dowel. I'm going to get rid of this for now. So now I know what my dowel size is. Current, I'm trying to see if I can salvage as much of what I've got without having to, not want to throw the baby out with the bathwater. So there's that one. If I duplicate that, Control D, duplicate it, and bring it up. Oh, I got those, didn't need to. See, I don't have enough room there. So that one will need to be lowered. But I believe I can make this work. Because if I can bring those, lower the bottom a little bit. All right, so now I've changed, by changing the position of where my dowels need to be placed, I'm going to have to change the size of my cams, my centrics. And to do that, I've got, this is my lattice. They're going to rotate here, and it needs to come up and contact the bottom of the maze, and it's going to contact the bottom of the maze on one point only, and then a millimeter less on the other side. So I'm going to just grab this guy. Did you say you tried 4 and 5 degrees of tilt? Yeah, 4 and 5, because my initial design gave me about 4 degrees of rotation, and the marble, you had no control. No control. You need 8 degrees of rotation in order to be able to control this top and make it a playable game. And let's group these together. They are grouped. All right. So bring this down here. And let's put that right there. And now if I look, see there, it's not touching. Well, If you're comfortable in Lightburn and you have a piece like this already, all you got to do is use your node editing to stretch these around. And I'm going to do that, but I'm also going to show you how to create these real quick. So that, because if you're going to do this yourself, you're okay, now I understand my pivot point and pivot point height. I understand where to place all this, but how do you draw those? How do you create those cams? Well, first I'm going to correct this one, then I'll show you how to draw one. I'm going to ungroup this, keep everything selected, go into node editing, grab every one of these on this round lobe over here, and I'm looking for where that makes contact with the bottom. Is, see, that's the lattice. No, I'm sorry, that's not the lattice. The lattice is down here. It's the tabletop maze. So I'm going to put it, we need to get a little more movement, or a little bit tighter movement. And I'm going to say 0.1. There. All right. And then come over here to this one, and I'm going to move it up, and I'm going to put it exactly the same. And then what was my movement? Which one gave me 1 millimeter? This one will give me 1 millimeter. Say okay. And now with those selected, I'll just move it down 1 millimeter. Up, not shift 1. There we go. That's 1 millimeter. So now I have modified that to fit that box design. And I've got everything still selected, so I can just regroup it and then just drag that out of the way. So now I've got a modified cam for that. But now you need to create one, because if you're drawing this yourself, you've already understood how to create your height. You know where your tabletop's going to be. So, and you've now positioned where your dial's going to be. Well, simply draw you out a circle. And let's put my layers keep going away. Have I got my zoom zoomed in? They go. Yep. If you noticed, I was zoomed in at about 175% or something a minute ago. And that, boys and girls, is why my color palette kept going away. I had my windows zoomed in, and that was causing it to drop off my palette every time I went to look at it. Put your zoom at 100% in Windows, and it'll quit dropping off that stuff. And Chris says, I just checked the math. 8.333333333333333 is optimal tilt. That's so 8 works. All right. So now I fixed my zoom. I've got my color palette to stay. There we go. Put that. So I draw out a circle. And if you're going to do a lattice, you need to know how wide, or you can design your lattice around your eccentrics. The further away from your center point, the more leverage you get. So it takes less effort when turning the knob in order to lift create the tilt. So you want to go as far out to, close to the perimeter as you can, and also as close to the corners as you can. So the further away and the further out, the easier it is to lift and tilt the stuff. Now, for me, to keep everything easy to design, squirrels are busy today. Yep. In order to keep the design easy enough to assemble, whenever I was figuring out my lattice here and the size of the cams, how wide are they going to be, I looked at whatever the measurement was of the lattice, which here in this case was right at 285 mil. And I go to node editor. Oh, it's not a shape. I got to convert it to a shape, or a path rather. convert to a path, go to node editor, and then I put a node in the middle by hitting the letter M, and that put it over there, and then I hit node M again. And right there is halfway between the edge and the center. And that's where I made my center point for my lobe. All right. Now, do you have to do that? I just did it for the symmetry and the looks whenever it's all put together. That just looks good. Don't know what that piece that I didn't need. So if that's the center, and remember if we grab our line, I'll look for that should snap in there somewhere once I get on a node, or it should. But when it don't want to, just go back, show your nodes. There it is. Now I'm going to get a circle. There it is. And I'm just going to draw a simple circle right there and then put that in the center of that. Now that tells me that position. And if I put that in the center of that, that tells me the position that needs to be. Now I'm going to lower that down to where it's making contact with my maze. There's one position. I'm not going to do that over here. I don't need to. Now I'm going to come over here, and if this is the size of my dowel, I'm just going to do an offset inward of that a little bit. There would be good. And say okay. Put that on. Now I just fixed my zoom. I don't know why I'm losing my palette. I thought I fixed that. There we go. Put that back there. So now I've got a circle, and I've got a circle that's in the right position. I can just draw me a rectangle. I don't even have to draw a rectangle. If I want to, I can just draw a straight line. Just draw a line from there to there, and a line from there to there. And then use the scissor tools and cut away the pieces you don't need. Delete that. I'm going to duplicate that, bring that up here, duplicate that again, and mirror it. And if I had my, there we go. That's the center. And I don't even have to get too crazy about it, but I'll move that in a little bit. There we go. And then just weld those together. And there, by only creating one side of it, now I have a symmetrical piece. Now I just need to lower that one down 1 millimeter. I can get rid of that one. Come in here to this, select node editor, and bring it down 1 millimeter. Done. And then I would put some type of X marks the spot as to which one has got the side that's lowered down a little bit, and put that on the engraving, or you can cut it out. It doesn't really matter. I probably missed it, but did you use craft cloth? Yes. I didn't talk about the materials in tonight's video, but yes, I initially did it the 3mm Baltic birch. Not satisfactory. I had enough of this left over that Russ sent me from Craft Closet, and I am in love with this stuff now. I before being introduced to Craft Closet's MDF, I told people to stay away from MDF. It was garbage. It was junk. It was sawdust glued together. Well, this is not junk. This is extremely laser friendly. This is extremely nice stuff, and it's not cheap. But the finished product is 10 times more attractive than anything you can do with the Baltic birch. Having all the different colors and the variations, it looks super, super slick. And it's stable. You don't need a tabletop from your maze that looks like that, where it's completely warped, and or it can change depending on the humidity in the room at the time. So the MDF is the way to go. The Craft Closet MDF. I used what I had. I've got more coming to be here on the 7th or the 9th. And so hopefully by the time I got the redesign done, I'll have my new material here. But Craft Closet's MDF, spot on. All right. So there is one I've already got corrected. I'm going to get rid of this. I was just showing you how to do that. I'm going to work with the ones I've already done. I'll drag that one. There. And now look at what modifications I need to make to this one. Ungroup, node editing. Oh, I wish it, see, there we go. And group that back together. And those are modified. All right. Those may be the only changes I need to make to my design once I get the new material here, get these cut out and see what happens. I have the same issues with the Baltic birch as you. I'm also switching to craft. But it depends on what you're making. I like my Baltic birch. I like my Baltic birch for doing my arts and crafts and doing the small stuff. But when for this purpose, having that stability is crucial. Because that Craft Closet, it's not cheap. Now, if you're not aware, and I was told by the guys at Craft Closet, they prefer you ordering it from Amazon. Let's go. There it is, Amazon orders. Yeah, I just bought $100 worth. I just ordered this. It's $100 for 17 colors. I mean, 17 sheets. $100 for 17 sheets. That's expensive compared to the Baltic birch. That's really expensive because you're getting 45 sheets for, I don't know what it's going for now, but that's a whole lot more expensive than the Baltic birch. But Craft Closet, Let's see, color let's see, unfinished wood products, MDF wood core. I don't want you, go away. I would finished products, MDF core there. That's not what I'm looking for. Colorboard expressions. Nope, that ain't what I'm looking for. I was looking to compare the prices because he did tell me he preferred, because I had asked them about doing a yeah, and I do, it's 12 by 19 instead of 12 by 12, but I asked them about me getting a code that I could refer you guys to, and they're like, nah. By the time we do that, it ends up costing everybody more. It's just send everybody to Amazon. Yeah, they're good. Fowler's good. Steve, so is outside box about 10 millimeters taller. So is the outside box. Well, in this case, it was, by the time you do the pivot point, this one wasn't tall enough. That's why I just stretched it out. And whenever we go back over there, what is it? And I don't know that this is enough or not. Let's take this, put it bottom, and rotate it 8 degrees. 8 degrees. So there's what little bit would be protruding. So there, at full rotation, if you wanted to have the tabletop, the maze completely, constrained, not ever popping up, then you would need to lift that even further. Like that. But that may be what I end up doing. But what I'm looking at before I start putting the final dimensions on that is the material, because the way I had it set up, I was able to get all 4 sides out of a single 12 by 19 piece of material. So the sides was done with one piece of material. And now that I'm having to make that taller, I ain't gonna be able to do that. But I had a lot of waste on here and here, so I can make 2 here and 2 here and still not use any more total material than I did initially. So I'll be looking at that before I put my final dimensions on the actual height of the box. It also, yeah, and that's what these are 12 by 19 sheets that I ordered, 17 of them for $100. It looks like Craft Closet has the same. Well, I have to double check that. And if that's the case, then I'm going to contact him back and tell him, hey, why did you tell me to do that? Because you just cost me $25. I don't know if it's the exact same pieces or not, but I'll double check it. And good looking out. All right. So guys, gals, thank you for hanging out. This was a little different because I wanted you to see that entire journey because when I get this thing finished, it's not going to be a piece that it works. It's going to be a piece that's going to be precision built, and it's going to work like a champ. And it'll be worth the $9.99 that I'm going to have it on my website for. This will be a $10 project on my website. And that doesn't even begin to reflect the amount of hours I've got in it and or the materials I've got putting in it. But I wanted you to see, the process, the whole thing from start to finish, all the failures and the dead ends, and also now you've got a better idea of, okay, the things that you need to think about if you're going to start doing something like this yourself, roadblocks and stumbling blocks that may not have even been in your thought process. Before you go, how's the RV hunt? Well, I missed a couple others. I see you, Chris. The RV hunt I've put on hold. My floor is spongy. Obviously, MDF has gotten soaked. There's 2 inches of water standing on it. My floor is soft and sagging, and it ain't gonna hold up for long. But right now I've got so much other going on. I needed to get the website finished. In fact, let me show y'all a preview of the new website. I don't think I showed you this yet. I don't think. I might have. Um ba, 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 ba. Where let's see, search. There we go. And yep, there we go. And make sure this is it before I switch you over. Yep, there we go. So new website's going to look something like this. Whenever you land on the web page, you're going to need to log in. You're going to have you're going to have free memberships available. You don't have to pay to go in, but in order to download from anything from the website, you got to be logged in anyway. So to get into the site, you're going to have to log in first and foremost, either with your free account that everybody can have, or as your sponsored account, gold, silver, or bronze. You're going to log in. Then once you log in, it's going to direct you to the digital files. And nice, clean, much cleaner layout than what I've been doing. Organization's a whole lot better off. And then I'm going to have the videos page will be for the paying sponsors. And that's where I've been doing the Patreon videos. That's where the videos will be in here, but only paying members will see the video pages. So I put the RV thing on hold because I have been chasing my tail, driven down to Helen, Georgia, and this is no joke. I went to hell and back. I went to Helen and back, trying to find an RV, and waste of time. I've been to multiple places, looked at a bunch of stuff, and I don't want to make a rush decision. So I'm just waiting. I said, okay, nothing's where I want it to be price wise. I was just waiting. So there's where that's at. And what did I missed a comment from Chris? Chris. There it is, Chris. The sides need to be a minimum of 0.6 diameter of marble at lowest point. To keep it, the sides need to be. And I'm guessing you're talking about the sides of the maze. And that's what I was talking about. The sides of the maze need to be about twice. You got 0.6, and I think it said it needed to be almost about half the size of the marble. You got 0.6, a little over half. And that's why I said I would probably, in my final version, if I'm going to do it all out of this, I'll probably do a second layer of the maze identical and glue it on top of this one. So the maze would be 6 millimeters tall. That's still going to be just a little bit less than half, but I'm not going to spend the money on a third layer and make it 9 millimeters tall. There would be the idea would be maybe you go to a smaller marble. But I designed the maze itself so that a 16 millimeter marble, where my marbles, I've done lost my marbles. I'll just take another one out of my lamp. I designed the maze so that the size of the marble would work, the walls, or the spacing was done for the 16 millimeter marble. So if you're going to do a maze and use something smaller than the 16 millimeter marble, then you would want to design your walls or your closer together for optimum play quality. $15 shipping. Oh, and you know what? That might be the difference in the website pricing versus Amazon pricing. I'm Amazon Prime, so I don't have any shipping involved. So maybe that's why he was saying, hey, just send it over to Amazon. And because he did tell me the logistics, they prefer people buying it from Amazon, so they don't have to mess with the shipping. And let's see here. I missed what Carl said. What is he? Asking questions also helps in designing. Thank you. Yeah, it's coming together. It will be the same. It'll be the same. HoboWithWood.com. I don't have it. It's not live yet. I'm still working on getting everything cleaned up and designed. Well, the reason it looks cleaner and more professional is because the professional is doing it. The other one looks like a 6-year-old did it because I did it. And I'm not a web designer. And I'm going to critique a few things about this, but this is looking really, really good. And this web designer is the same web designer I used for my tire store when I had a tire store. Let's say if you can dream it, you can do it, but you say you don't have the imagination. That's what you Google for. You go get on Google and just say, show me popular laser designs, and just start, popular laser cut designs, and start looking at different things people are doing. And you might get some inspiration there. And then plus, I used to spend in my early days, I spent a ton of time just walking through Hobby Lobby with my phone out, taking pictures of everything that was selling in there, because if it was popular and people were buying it and I could recreate it, I didn't have to come up with the idea. Somebody else already had it. I just need to create it so I can make it on here. That's like, this isn't a new idea. There's tabletop tilt mazes been around forever, but and there might even be one I could go online and buy. Maybe, I don't know. I didn't look. But I don't want a maybe that might work. I'm going to design one that I know works and will be perfect and be flawless, and then be able to put on my website. Yeah, and that's you start even using some other files and designs, and then figure out ways that you can make them better, because there's always another way, and there's things that can be done to tweak them and make them better. Would there be a way to swap out different mazes to keep the challenges ongoing? And I thought about that too. This is a separate piece. You can have many of these pieces. You can have these stacked in your shelf, like your LPs. You remember LPs? Do you know what an LP? Do you even refer to them as LPs? All your albums. Put these in there. Put them on your shelf with all your albums. This MDF is not going to warp up like the plywood if you put it on its edge. Shouldn't. Not as easily. But you can make as many of these as you want to. That could you can switch them out. They're not attached. They're floating. So you could have as different mazes, many different mazes as you wanted. Yeah, and Missy, that's the biggest thing. I haven't been getting a lot of requests lately, but there for a long time, the most request I got was people, they bought designs that weren't created in Lightburn, So they weren't light burn friendly. They wouldn't work with the resizing slots and selection tool. There were tons and tons of open shapes, and so it created all kinds of issues and problems. If someone's offering a file for sale and they do not explicitly say that it is light burn friendly or created in light burn, I wouldn't want anything to do with it unless you're comfortable in your own skin and being able to fix all the problems. All of my stuff, I design everything 100% in light burn. That's why I'm having some of the struggles that I have, is because I think Steve Ventari, I think he uses, I think one, I don't know if it was something called SketchUp or something, but it had a 3D ability that, and it could actually show you the interferences. I think he was telling me, to where you could see the problems before you didn't have to actually cut them. You could see that this ain't going to work, or this. And I don't use any of that stuff. There's nothing wrong with that. I just don't know how. So I struggle to get it through with light burn, but when I get it done, it's going to work. Join the rest of us. We've lost our marbles. There you go. All right. Yeah. Hey, I had 78s too, brother. If you make the base deeper, you may be able to store them in the underside. There's nowhere to access it. You'd have to create a place to do that, and then I could just see that being potentially. There's no room inside. There's no room inside at all right now. My cams here are loose. The eccentrics. There we go. I don't have the knobs glued on them, so they're sliding out of place. But the box is full. There is no room inside there. That bottom axis is just off the floor. There's no room to put anything inside this. So that's a big box, but it needs to be that big in order to get all the pieces in there with the clearance that it needs. Chris, you are very handy to have around. Yes, Chris is a blessing. Chris is a blessing to all of us. I remember when my daughter was little and she found one of my 45s, said, "This won't fit us." I thought the top piece was going to be fixed. No. The top piece doesn't. In my design, the top piece doesn't get fixed. The way I intend to do it is I will have my raised center point here with my marble in it. The walls are going to be taller, and this just sits in here and is floating on that pivot point, and using the eccentrics to lift and tilt it. It's just sitting on that pivot point. How are you going to stop the side? It's not piston fit, so it has room to move. But what little bit it slides and moves around, the walls constrain it. It can't go any further than it works. It works. And that's why, because I am lifting the center point, that's why this won't work. I've got to make this taller, because if I tried to leave this as is and I lifted that up another 10 millimeters in the center, then it could be a problem. But by having the walls high enough to constrain it, it's not a problem with what little bit of slippage is on there. That was part of the math that ChatGPT did to figure out the optimum size, so it has enough room to tilt, but not enough room that it slides too far, and then now it gets out of whack. Uh, you could make the base wider at the bottom and the top smaller. Oh yeah, 8 tracks. Yeah, I remember 8 tracks. My goal this year is to make gifts and they actually turn out the way they were meant to. First, I have to keep my laser connected to Lightburn. You guys are too young. My first recording was a wire recording. All right. Well, I'm not familiar with the wire recordings, but I am the clay disc or the clay drums. Uh, that's going way back in the day. Uh, all right. Well, good night, Missy. Thank you for joining in tonight. This is a long one. Uh, you've seen where my journey has been all week. I've been working on this, and this has been a good escape from reality. It's been frustrating and rewarding at the same time. And I look forward to having a completed piece, hopefully by this time next week, because I think it said the expect my delivery's going to come in orders arriving between the 7th and the 9th. So it may be here before my MDF may be here before Saturday. It may not. Don't know. All right. Port failed to open, already in use. Have you got multiple versions of Lightburn open? I do that, and that can cause a problem. And make sure if you have multiple versions of Lightburn open, if you don't already have a ghost machine created in Lightburn, you need to create a ghost machine. And let's see here. Let's go back to Lightburn. Here I've got one version of Lightburn open. If I open up another window, file, open, new window. And there I've got the XW connected. Here, there's no machine or a ghost machine. This way you can have multiple Lightburns open and it not have a communication issue. But yeah, if you've got them, 3 or 4 open, you can only have the laser connected to one version. So I don't know if that's what maybe you're running into. And Chris is saying it's a operating system problem, but and it, it could be issues with your USBs, or it could be that you've got multiple windows open in Lightburn. But now, Chris, mine still does this, and maybe this is the problem that Melissa's having. I can connect and I can use my Rolly for 2 or 3 hours, no problem. When I'm done, just because I don't want to listen to the fan running, I can reach back here and turn the laser off. Laser's off. Fine. Come back here and turn the laser on, and then go back to trying to use Lightburn. It won't connect. It won't connect. I have to go in and left click and reset the devices to get it to restore the communications. So there is an issue within Lightburn that it won't reconnect to that machine until you reset it. So Melissa, if you may try that too, if that's what you're having. If you've been using it and you go back try to use it, don't just left click on the devices. Come over. Let me turn the comments off. come over here to your devices, and not left click, right click. Right click, and that the right click will reset your connection. Right click. I don't know my left from my right. Right click resets the connection. Jack says you could have one more layer attached under. Yeah, so you could do a double-sided. I think it's what we're talking about, doing a double-sided maze. I think. Chris says multiple ghosts for each laser. Yep. I don't even bother with the different. I just my ghost laser, my ghost machine is just a 12 by 12 work area, and I go. I have that same reconnect issue with my Mac computer. Yeah, and that's why I say it's not a. I don't think it's a laser problem or a computer problem. I think it is an issue within Lightburn, because there were some folks that saying they were having problems and that Lightburn made some corrections and fixed some things, but there's still an issue with connecting to the Rolly. It just won't do it. I have to reset it. But Chris is saying, yep, that's an operating system not reinitializing the port. Lightburn thinks it's still connected. Well, it never, ever, ever did that. Ever until I went away from 1.7. But in fact, I would be willing to bet you, Chris, that if I rolled back to 1.7, it wouldn't be that problem. That problem wouldn't exist. So, anyway, I arrived a little late. We'll need to go back and watch from the beginning. I will look into both suggestions. Mac here and says waiting for connection. Thanks for the effort to assist. You're a Mac user. I forgive you. Actually, the more creative folks is the way I understand it. And that's really kind of funny. You say you're not creative. That's usually, and Jack says, I like my 1.7. Yeah, buddy. Yeah, for real this time. Sweet dreams. Just don't let your husband know it was about me. It's our secret. All right, boys and girls. That's it. I'm calling it 2.5 hours. It's longer than I anticipated. Thank you all for hanging out for a while. And again, I don't know if Chuck's here or will see this, but God bless you, Chuck. Thank you. May God keep you and bless you throughout the upcoming year. Bob, same to you, sir. The support I get from my patrons and my supporters, and Missy, she's already gone. God bless you and thank you. And I will see you guys. Oh, so what was Chris saying? Chris is saying in 1.7 and 2.0. 1.7 and 2.0 talk to the operating system differently, trying to solve a multitude of problems. Yeah. So then I go back to then that it's not the operating system, it's Lightburn. Because Lightburn's doing it differently. Then 2.0 is doing it different than 1.7. So the change there was Lightburn, not the operating system. And again, like I said, I get it now. After I've done some of my own coding and realized the headaches that you run into, you fix one problem and create 3 more. Man, I am not begrudging anybody about those small mistakes or problems. Not even mistakes, small problems. The gremlins will pop up. And there's nothing you can do about it. So, all right. So, good night, everybody. Happy New Year. And we will see you later in the week, or if not later in the week, we'll see you Saturday night. Y'all have a good evening.